Hello students, today we will learn homogeneous differential equation. Before that, let us understand homogeneous function. So we say a function f of xy is a homogeneous function of degree n if f of lambda x over lambda y is equals to lambda raised to the power n into f of xy. Let us understand this through some example. So our first example is very simple, straightforward example. Here our function f of xy is x plus y. You can see each term have degree 1, so it is homogeneous. However, we verify through this simple definition. So simply plug lambda x in place of x and lambda y in place of y. So we get lambda x plus lambda y. Now lambda is common. So let us write lambda times of x plus y. So this is lambda times of f of xy. So it is a homogeneous function of degree 1. Okay, let us see one more example. Say our function f of xy is x square plus y square. Put lambda x in place of x and lambda y in place of y. So we get lambda times of x whole square plus lambda times of y whole square, which becomes lambda square times of x square plus y square. And this is our original function f of xy. So we can rewrite this as lambda square times of f of xy. So it is a homogeneous function of degree 2 since exponent of lambda is 2. Let us see one more example where f of xy is not homogeneous. So let us say f of xy is simply x plus y plus some constant, say 5. So this time if you plug lambda x in place of x and lambda y in place of y, then we can rewrite this as lambda x plus lambda y plus 5. This cannot be expressed as lambda raised to the power any number into f of xy. So this is not a homogeneous function, not a homogeneous function. The first one is a homogeneous function of degree 1. The second one is a homogeneous function of degree 2. Let us see one more example where f of xy is simply a homogeneous equation of degree 3. Say this time our function is x cubed plus y cubed. So we can see since exponent of x and y is 3, exponent of each term is same and that are equal to 3. So if we plug lambda x in place of x and lambda y in place of y, then we end up getting lambda raised to the power 3 times of f of xy. As a result, we can say this is a homogeneous function of degree 3. Now let us understand what is homogeneous differential equation. Okay, so a differential equation of the form dy over dx equals to f of xy over g of xy is called a homogeneous equation if f of xy and g of xy are homogeneous function of same degree in x and y. Okay, otherwise we can say homogeneous differential equation can be written as dy over dx equals to f of y over x. Let us understand through example. Suppose we are solving a homogeneous differential equation dy over dx equal to x square plus y square over xy plus x square. We can see our numerator is a homogeneous function of degree 2 because each term has degree 2. And our denominator is also a homogeneous function of degree 2. So our numerator and denominator both are homogeneous function and both have degree 2. So this is a homogeneous differential equation. And we can rewrite this as f of y over x. How we can do this? Simply divide numerator and denominator by the highest exponent of x. And here highest or degree of numerator and denominator. So here we divide numerator and denominator by x square and we get 1 plus y over x whole square plus y over x plus 1. We get this expression once we divide this numerator and denominator separately by x square. And we can see this is a function of y over x only. So we can rewrite this as some function of y over x. Now we will learn how we solve a homogeneous differential equation. Okay, so process of solving a homogeneous differential equation is very simple. Suppose we are dealing a homogeneous differential equation where our homogeneous differential equation is f of xy over g of xy. So we can express this in the form of fy over x because degree of homogeneous function in the numerator and denominator are same. So we can express this homogeneous function as some function of f of y over x, and then we simply put y over x equals to v, or we can cross multiply and say y equals to v over x. Then differentiate both sides with respect to x. We end up getting dy over dx equals to v plus x dv over dx. So basically substitute v plus x dv by dx in place of dy over dx, and in place of y over x, substitute v. So we end up getting v plus x dv over dx equals to f of v, and then transfer v to the right side, we end up getting x dv over dx equals to f of v minus v, and then we manipulate this, and after we can integrate both sides now using method of variable separable, and we get some relation between v and x, and then finally we again use this simple relation to find our answer in terms of x and y. Let us understand this through example. Suppose we have to solve this simple looking homogeneous differential equation. Here we can see here exponent of y is 2, and here degree of each term is 2. So it is homogeneous, obviously. Now we can rewrite this equation as xy plus x square times of dy equals to negative y square times of dx. Now divide both sides by xy plus x square. So we can rewrite this as dy over dx equals to minus of y square over xy plus x square. Now we can see numerator, denominator both are homogeneous function of degree 2. So simply divide numerator and denominator over x square. So we can say minus y square over x square, or xy over x square over x square. What I'm doing here, we simply divide everything by x square, and we end up getting minus y over x whole square upon y over x plus 1. And this part is simply dy over dx. Now, just do one thing. Simply put y over x equals to b. Let us do this substitution here. Or let me. Okay. So let y over x is b. So cross multiply, we end up getting y equals to v times of x. Differentiate both sides with respect to x. We end up getting dy over dx. V times of 1 plus x times of dv over dx. Now substitute this simple substitution y over x and dy over dx in this equation, we end up getting dy over dx is v plus x dv over dx, and right side is simply minus v square on v plus 1. Now transfer this v to the right side, we end up getting x dv over dx equal to minus v square over v plus 1 minus v. Now take LCM and simplify this expression. So we end up getting v plus 1 minus v square minus v into v is v square minus v is x dv by dx. Now cross multiply, we can rewrite this v plus 1 over minus 2v square minus v dv equals to dx over x. Now v is common here and multiply both sides by negative 1, then we end up getting v times of 2v plus 1, and our numerator is v plus 1 dv equal to negative dx over x. Now we can write v plus 1 as 2 times of v plus 1 minus v over v times of 2v plus 1 times of dv equals to minus dx over x. It is very simple. We replace v plus 1 as 2v plus 1 minus v, so that once we distribute 2v plus 1 is cancelled and in other term v get cancelled. Now integrating both sides. Okay, so let us rewrite this. Integral of 2v plus 1 minus v over 2v plus 1 times of v dv equals to minus dx over x. Now distribute this denominator. So 2v plus 1 divided by this much is simply 2v plus 1 get cancelled and we end up getting 1 over v dv minus this time v get cancelled and we end up getting 2v plus 1 times of dv equals to minus dx over x. Let us see how we end up getting this. Here this is 2v plus 1 minus v over 2v plus 1 times of v. So this can be rewritten as 1 over, you can rewrite this as 2v plus 1 over 2v plus 1 times of v minus v over the same denominator. So 2v plus 1 get cancelled and we get 1 over v minus, this time we get cancelled and we get 1 over 2v plus 1. Okay, now integrate this. So integral of 1 over v with respect to v is simply ln v minus integral of 1 over 2v plus 1 is simply ln 2v plus 1 over 2. Otherwise, we can rewrite that 1 over 2 times of log 2v plus 1 equals to minus ln x plus ln c. Here, ln c is simply constant of integration. Let us simplify this. So we can rewrite this as ln v over under root 2v plus 1. And here this side is simply ln c over x. Now we can remove log on both sides. We end up getting v over under root 2v plus 1 is c over x. Now on squaring both sides, we get v square equal to 2v plus 1 equal to c square over x square. Cross multiply, or now plugging v equals to y over x, we end up getting v square x square equal to c square times of 2 times of y over a 2v times plus 1. Otherwise, we can rewrite as vx is y. So this is y square equal to c square times of 2 times of y over x plus 1. This is the final solution of given differential equation. Let us understand through one more example that how we simplify homogeneous differential equation. So suppose we are solving dy over dx equals to x minus y over x plus y. So even before the start, we are able to see that this numerator is a homogeneous function of degree 1. Denominator is also a homogeneous function of degree 1. So this is a homogeneous differential equation, and it can be expressed as a function of y over x. So simply divide numerator and denominator by x. We end up getting 1 minus y over x equals over 1 plus y over x. Now putting y over x equals to v. So let y over x equals to v, or y equals to v times of x. Now differentiate both sides with respect to x as we had done in the previous question. We end up getting dy over dx equals to v plus x dv over dx. Now plug these two values in the equation, we end up getting v plus x dv over dx equals to 1 minus v over 1 plus v. Transfer v to the right side, it becomes x dv over dx equal to 1 minus v upon 1 plus v minus v. Now take LCM and simplify this. We end up getting 1 plus v, 1 minus v, minus v, minus v square times of x dv over dx. Now simplify this expression, we end up getting x times of dv over dx equals to 1 minus 2v minus v square over 1 plus v. Cross multiply, we get v plus 1 over minus v square minus 2v plus 1 equal to dx over x. We can rewrite this as v plus 1 into v square plus 2v minus 1 times of dv equal to minus dx over x. Now, if we assume our denominator to be t, so we get 2v plus 2. So we can multiply both sides by 2 simply. So we can rewrite this as 2v times 2 times of v plus 1 equals to 2 times of dx over x. Now, if we take denominator t, then numerator is basically f of t. So it becomes simply log v square plus 2v minus 1 equals to minus 2 log of x plus some constant say that constant is basically lnc. So we can rewrite this as ln c over x square equals to ln v square plus 2v minus 1. Now remove log on both sides and plug y over x in place of v. We get y square over x square plus 2 times of y over x minus 1 equals to c over x square. Now multiply both sides by x square, we get y square minus plus 2xy minus x square equal to c. And this is the required solution of given differential equation. Hopefully you find it helpful. Please do like and subscribe this channel. Thank you.